everyone, I am Dr. Jagadha, Professor and Head of the Department Mathematics, Institute of Aeronautical Engineering. Today the topic for the discussion, the subject is probability and statistics. The topic, area and a normal curve. The subtopics under which the area under normal curve, they are probability of density of normal curves and problems based on normal curves. So the introduction part, we can see it. The graph of the normal distribution y equal to f of x. We can see it. In the xy plane, that is a two-dimensional, is known as normal curve. And the curve is bell-shaped and symmetrical about the line x equal to mu. Mu is nothing but mean. And the area under the normal curve represents the total population. So the entire area, the total probability of that particular what is given is 1. So these all been points regarding the normal curve. So we can first the normal curve. To find the probability of density of normal curve, first we have drawn the normal curve. The previous slide, we have seen it is a bell-shaped. So you can see the shape. It's a bell-shaped. A vertical line which divides this is the complete area. So the area which is divided by this line symmetrically. That is, here how much area which is equal to this part. So both the sections, the area under which they are equal. So one more condition is there. That is, the total probability is 1. So here we can see 0.5. Here also 0.5. So the total probability is 1. Here z equal to 0. What is the question? That is, the condition is z1 greater than 0, z2 greater than 0. That is, 2 points are here. They are z1 and z2. They are positive. If it is not written here positive, but the greater than 0, which indicates mathematically that is a positive, then the probability of the question, it is there here. We will see it that afterwards. Satisfying this condition, z1 and z2 were to be placed. Here we can see it. Yeah. Z1 is greater than 0. It is placed the right hand side of, here our z is there. Our point is z1. Whether to the left or right side, we have to take the decision, that is right or left of this point z. As the given one is greater than 0, to the right of to the point z to be placed. So we have placed it. Another one z2 also it is greater than 0. That is also to be placed the right side of this z. Yeah, we placed it. Then what is our question? The question they are asking, the probability of z lies between z1 and z2. So this is the area we are asked to find. How to find? Under this normal curve, the area. The total area is 1, but what about our shaded part of the area? That is only our first the question. So we can see it. Yeah. So the question, actually this we discussed it. Here I wrote the answer also. The answer how we can see it. Z equal to 0. Yes. Z1 and Z2. This is the yellow color part, it is there, the shaded one. That area we are going to find. A simple logic, that is 0 to Z2 first we are finding. That is area of Z2 we are finding. And this part is there that completely we are removing. This calculation, this part we are removing. So the leftover, naturally we will be getting. So based on that concept, here it is written area of Z2 minus area of this Z1. We will be getting the shaded part area. So based on this concept, we are going to solve the problems. This is only this video lecture content. Yes. One more curve we can notice. Yes, our bell-shaped normal curve is ready. The symmetrical line is there. So at the point Z equal to 0. Now the question is Z1 is less than 0. Where to be placed? That is, the Z1 to be placed whether left or right side of Z. It is left side because the symbol which is given here less than. If it is less than, left side to the point. If it is greater than, right side to the point. It's a very simple logic. Yes. Now, according to this question, we will place in the diagram. Yes, Z1, it is placed to the left of the point Z, Z2 to the right of this Z. It's very simple. Yes. What we are asked to do it, Z lies between Z1 and Z2. So, here the question we can see it. We are shading the area because Z lies between Z1 and Z2. Yes, here the answer which is written. Here we can see it. Z, Z1, Z2. This is the fair diagram. This fair diagram, to get what are the background diagrams, that is only in the previous slide. Step by step it is shown. So Z equal to 0, Z1 and Z2. So here this part first we are calculating. This particular the yellow color shaded one. This part 0 to Z1, area of Z1. 0 to Z2, that is area of Z2. Fine. So area of Z1 plus area of Z2. So one more we can see it. Z equal to 0. Yes. Now Z1 greater than 0. That is right side of to the point this Z equal to 0. Yes. We can see the second diagram, how we are going to place. Here our Z is there. We placed it here, that is the right side of Z1. So it's a very simple logic to the students community, where you are writing, your right hand is the right side of this point. Simple thing, we can avoid the careless mistake. So this is the answer. The question is Z is greater than Z1. That is right side of to this point Z1. We can see the fair diagram. Yes. Yes. Now it is Z1 is ready. This area is 0.5. This area is 0.5. Our 0 to it goes on infinity towards positive, and this goes on minus infinity. Now 0 to it goes on. The area is 0.5 only. So now we needed this, the point, the color which is shaded in a different color, the yellow one is a shaded part. We have to find out the area. Fine. Now here complete the part is 0.5 that we have written. Complete part. This part we are going to subtract it. Naturally we will be getting the leftover shaded one. So the concept based on this, finding the areas, we are going to solve the problems. Yes, the first problem is, if x is a normal variate with mean 30 and standard deviation is 5, find the probability that x lies between 26 and 40. X is greater than or equal to 45. What is given? First we are writing, given mu equal to, that is the question mean is given. The symbol is mu. So mu equal to mean equal to 30. Next one is sigma equal to standard deviation equal to 5. What is given? The data are first we are writing. The second one is the probability of. Find the probability that. So the probability of, first this question we have written here. The 26 we have given the name. We denoted by the variable x1. This 40 we have given x2. Next, x1 equal to 26. If you want, we can write it. Probability of. This name is, we have given x1. Fine. Just now we discussed the normal curves area under three different the diagrams. We discussed it. We plotted the points z1, z2. But here the question is x1 and x2. To plot in the normal curve, the scale is required. What is that scale? With that help of that scale, this x1 to be converted into z1. This is our scale which is going to convert our x1 as z1. So z1 equal to x1 minus mu by sigma. So z1, what are the values we obtained? Here we can see it. This is our x1, 26. This is our, just a minute, mu, 30. Sigma is 5. So we obtained our x1 is given 26 with the help of this scale. Mean and standard deviation is given. Two methods are there. The first method we are discussing in this video lecture, mean and standard deviation. Both the values are given, we are discussing. If they are not given, there is a next method. Now, x1 is converted into z1. We found the value minus 0.8. Next, x2 is 40. Yes, here is our x2. That x2 we are converting into z2 to plot the normal curve. That is only our goal now. So z2 equal to x2 minus mu by sigma. Our x2 is 40. We substituted in the particular places and mu is given and sigma is given. That is mu is 30, sigma is 5. we substituted, here the mistake is there, this is Z2. So Z2 equal to 2. Very clearly, the question what is given, x lies between 26 and 40, x1 and x2, the name given, and with the help of this scale, we converted into z1 and z2, we obtained the result 0 minus 0.8 and 2. Yes. Now, how to plot our z1 and z2 in the normal curve? Yes, our normal curve is ready. This is only our question. That is probability of x lies between 26 and 40. X lies between x1 and x2. That z1 and z2. So we will plot it now. What is the result we obtained it? z1 equal to minus 0.8. z2 equal to 2. Here is our middle, the point. That is the vertical line touch the point z equal to 0. Minus 0.8, the value is negative. We know this normal curve 0 to minus infinity left side. Here 0 to infinity is our right side of our z point. Minus 0.8 to be plotted left side, we plotted, and we have drawn a vertical line touching the point z1. z2 is positive. As it is positive, right side of z we have to plot it. We plotted. Clear? Yes. Now, the question is, z lies between z1 and z2. This shaded part to be, we have to find the area between z1 and z2. Yes. Here we can see it very clearly. The question is there. z1, what we have obtained it? Minus 0.8. Our z2 we obtained is 2. Yes, z equal to 0. z1. Here is our z2. This part we are going to first calculate. That is area of z1, and this part we will calculate, that is area of z2. Then which is shaded, the different color, the yellow one, where it is shaded, the complete part we will be getting using area of z1 plus area of z2. Yes. Now, area of minus 0.8, because we obtained z1, the value is minus 0.8. z2 value we obtained 2. Now, area of minus 0.8, we have written 0.2881. This how we obtained. The table, normal distribution table, using, we found this value 0.2881, whereas area of 2, the value is 0.4772 we found. So 0.7653 is the shaded area satisfying this question. That is, x lies between 26 and 40. Yeah, we can see it here. Yes, the question, the first question, this we focused it. This, the scale which is used, and here we used it. this point, it's converted into Z1, and this point which is converted into 2. The background diagrams, we have drawn it here. Very clearly we placed it. Yes, here this is the final result. We obtained it 0.7653. Calculating this complete area 0 from left side of Z, right side of Z, that is area of Z1 plus area of Z2. So final answer is 0.7653. The same one, two part is there, the questions. The one more question is, just first we are drawing, x is greater than or equal to 45. Now, the 45 we are assuming as x1. Before the problem is, x lies between 26 and 40. Two numbers. So, 26 we have taken as x1, 40 as x2. But here, the only one number which is given here, that 45 we are assuming as x1. So when x1 equal to 45, we have to convert it into z1. To convert that, this is the scale which is changing the scale. The change of scale from x1 to z1. Then only it is possible for us to plot in the normal curve. So we are substituting. X1 is taking the position, the value of 45 at mu 30 sigma 5. This method, mu and sigma, when they are given, that is their values are given, that method we are concentrating. We substituted. So 15 by 5, which is equal to 3. So the conversion part we completed. So z equal to 0. Z1 is 3. That is positive. If it is positive, we know very well the right side of z equal to 0, the point to be placed. That is the reason that Z1, it is placed to the right side of this point. The vertical line is drawn. So background of this question, the diagrams are written. We will move to the fair diagram. Yeah, this is the fair diagram. That is, yeah, we can see it here. The question, x is greater than or equal to 45. 45 x1. X1 is converted to Z1. This is the easy steps. If it is written, we won't get any careless mistakes. Then, this formula, how we have written. Very simple logic. How to read this first? Greater than comes right side of Z1. Right side of Z1. Our point is here, Z1. To this point, right side we have to shade. It goes on up to infinity. But this section, half section, area is totally 0.5. That mathematical thing we have to obey. This is 0.5. Total probability is always 1. So the total this section, what is our question which falls on this particular area. So now here, this is infinity. The total is goes on 0.5, from which Our aim is shaded. That is the yellow color one which is shaded there. Why this side we shaded? Why we didn't shade this side? The reason is here we can see the point greater than right side of to the point Z1. Because of this condition, that purpose, the Z1 right side part is shaded. This point, while the students should be very careful. So now we shaded this complete area we are finding 0.5. This part we are going to subtract the leftover, we will be getting the shaded one. So 0.5 minus area of Z1. The previous slide, that is the change of scale using x1 minus mu by sigma. Using, we obtained the value 3. Now area of 3, using the normal distribution table, the value what we obtained 0.4987. So that is 0.0013. So we can see this is the question we started for this first problem we are focusing now. The first problem itself, two sections are there. First section, x lies between 26 and 40. The second part is x greater than or equal to 45. So the greater than or equal to 45, first we found this 45 which is converted into the value 3. The name is Z1. The 45 name is X1. So from X1 to Z1 we moved or we changed. Then this is the background of the diagrams, these two diagrams to help to get our fair diagram. Yes, this is our fair diagram. This only the students should present in the exam. Yes. Now, the first problem, we have seen the values. How to get those values? Just actually we have written 0.288. We can see the values. Here also we can see it. Here the value. While explaining, I told we are using the normal distribution table. This how we obtained. We can see it practically. Yes. Yes, the first question, that is a 20, x lies between 26 and 40. This 26, that is x1, we converted into z1 minus 0.8. The minus 0.8, here one more point, we have to be very careful. Here minus is there, but here there is no minus at all. Here the scales, if you are noticing, there is no minus at all. The logic is, this is our normal curve. In the normal curve, if it is negative, we will go to plotting left side. If it is positive, we will move to right side. The area is 1. So that is the reason here area, all the things are written in positive. To make the difference, whether we have to move left side of this symmetrical line or right side of the symmetrical line, purpose only this negative sign. This point to be noted. So now, whether it is minus 0.8 or plus 0.8, the area is same only. Here is our 0.8. Just we will move here. This is our point 0.2881. That's what the previous slide we have seen it. Z2 equal to 2. That is our 40 we converted. We have given the name x2 and we converted into Z2. The Z2 is nothing but 2. Where is our 2? Here is 0.47772. One more, the second part also we have seen it. That is 3. Similar way we have to see it. So you can see the values here. Yes, this is the value just now what we have seen it. It is placed here. Yes. Now we completed one problem completely. We will move to the second problem. The second problem is the mean and standard deviation of the marks obtained by 1000 students in an examination are respectively 34.5 and 16.5. Assuming the normality of the distribution, find the approximate number of students expected to obtain the marks between 30 and 60. The first point, while reading the question itself, we have to analyze what is given, whether mean and standard deviation both are given or not. Two types only. If they are given, this is the video lecture what we are doing, the problems which comes under that. If it is not there, that is a method 2. Now mu, what is given? The data first we are writing. Given mu equal to mean equal to 34.5. This is the symbol for mean. Standard deviation which is given 16.5. The symbol is sigma. So x lies between 30 and 60. That is the question which is given here. 30 and 60. Our 30, the name we are giving x1. 60, the name we have given x2. But it is not possible this 30 and 60 to plot in the normal curve. It is not possible because to plot in the normal curve, z points are required. That is, we need the scale. Our scale is, first we are taking when x1 equal to 30, z1 equal to x1 minus mu by sigma. x1 which is replaced by 30. What about our mu? Mu is 34.5, sigma is 16.5. We substituted and we obtained minus 0.27. That is the lowest form of this 4.5 divided by 16.5 is 0.27. So minus 0.27 we obtained at the point x1 equal to 30, which is converted into z1 using this formula minus 0.27. So a particular part, the 30, the related, what is the work to be done, it is completed. Now our next step is to move 60. Our 60, the name is x2. Yes, x2. That we have to convert it into z2. x2 minus mu by sigma, we are substituting. Here x2 is 60. Mu and sigma which are given, that the particular, the respective places we substituted. We obtained the result 25.5 divided by 16.5, 1.54. So now the points are, our z points are, they are ready. z1 is minus 0.27, z2 is 1.54. So z equal to 0. So we are going to, this is our normal curve. What is the bell-shaped curve? First we are drawing z2, that is 1.54. We can see it here. So z equal to 0. Now the z1, we placed it left. to the left of this z equal to 0. Why we placed it to the left of z? Why not right of z? Because of this negative sign, we have taken the decision that compulsory it should be left side of z. So it is placed at the point z1. We have drawn a normal curve, that is vertical line to touch the normal curve. Next, our point is z2 equal to 1.54. So at the point z2, we have drawn a vertical line z2. So this is our question, that is probability of x lies between 30 and 60. We can check whether we are writing the answers in a correct way or not. Just a fraction of second, we can recheck ourselves. This is our question. 30, I named it as x1. 60, named it as x2. x1 converted z1. x2 converted into z2. Our z1 is minus 0.27, z2 is 1.5. They are placed in the diagram correctly. We will move to the fair diagram now. Yes, this is the shaded part, the pink color which is there. That is only the area to be found according to our question. What is the formula we have to? Very simple one. This pointer to be very clear to us when we are writing, when we are calculating the area, that z equal to 0, the point to be included. There, if it is not, we are doing the calculation in a wrong path. So now, this part we are calculating. So from 0 to z1. So we are writing once again. First we can see it here. z1, we obtained it, minus 0.27. The particular place which is written. z2 is 1.54. That we have written. This is the formula. That is, according to this problem, here it is there. Part first, area of z1, and this part. This is area of z2. So easily we can calculate z1, which is replaced by our calculated point using the change of scale, x1 minus mu by sigma, that is minus 0.27. Here the change of scale, x2 minus mu by sigma, that is 1.54. So now, using the normal distribution, the table, that is the value is 0.1084. Here we can see it, area of 1.54, the value is 0.4382. So we added, so the modulus, the absolute value, 0.5466. This is using the normal distribution table, we found it. So fine. Now the question is, x lies between 30 and 60. We converted, everything is over. But the question itself, this is for each student we have done it. But the question which is given, 1000 students are there. That is, the number of students who got the marks between 30 and 60, the total is 1000 students. That is the reason what this area we obtained into 1000 which is given. Suppose if it is not given, we can stop up to here. So 546.6. So roughly we can say it's a student. So 547 students got between 30 and 60 marks using this normal curve. The change of scale using we obtained very simple way among the 1,000 students. 547 we obtained the result who secured the mark between 30 and 60. So we can go back to the question. This is the second problem. We solved it because of this 1,000 students, the result we multiplied. This is the rough actually, the background of the diagram to get the fair we discussed. This is the final result. We obtained it. So now the table values what we substituted in the previous thing. That file we can see it. Minus 0.27. Yes. 0.27 we have to see. Here, this is the scale we are searching. Yes. Easy way, 0.27 is there. We want it. 0.2. Next, 0.07. It's nothing but 0.27. So the best thing, it's a very simple logic straight away like this also we can do it. But while doing mathematics, we should not give room for committing mistakes, errors. So 0.27, I needed that. So 0.2 plus 0.07 if it is there, I will be getting 0.27. I circled here 0.2. More what I should circle? 0.07. So I am moving here. Just I am moving. Yes. What is the targeted value is? Our targeted value is 0.27. So 0.1084 is the particular at this point the area. These are all our points. Z1, Z2, Z3. This complete their areas. Next one is 1.54. So we needed 1.54. So 1.5 is there. I want 1.54. So 0.04. So 1.54. It's a very simple, without missing any steps, each and every line which is we are discussing in this video lecture. So now 1.5 here is there. Next 0.04. Just we are moving. Yes, this is the way here 0.04. So our value at this point, our point is Z2, 1.54, the area is 0.4382. This is the way the normal distribution table we have to use. Yes, now we will move to the third problem. For a normally distributed variate with the mean 1 and standard deviation 3. The first target while reading the question, mean and standard deviation are given. Fine. Find the probabilities that x lies between 3.43 and 6.19. Now our x lies between minus 1.43, 6.19. Solution. So what is given the data first? We are writing mu equal to mean equal to 1. The standard deviation which is denoted by sigma which is equal to 3. X lies between 3.43 and 6.19. Our 3.43 we have given the name x1. 6.19 the name we have given x2. So x1, 3.43, we have to convert it into z1. So the change of scale, x1 minus mu by sigma, we are substituted 3.43 minus 1, the complete divided by 3. This 1 and 3 which are given in our equation itself. So the calculation part, we obtain 2.43 divided by 3, it's nothing but 0.81. So the from x1 which is converted into z1, that is 0.81. The next one is x2, 6.19. Change of scale, x2 minus mu by sigma, z2, 6.19 minus 1 by 3. So 5.19 divided by 3, which is equal to 1.73. So the curve, we have the normal curve. Our points are, that is z1, 0.81. Positive. If it is positive, right side of this point. So the question, so whether we are moving in a correct path or not, we can check it. A fraction of second. Yes, 3.43 x1, 6.19 x2, x1 is converted into z1, x2 which is converted into z2. Z1 and Z2. Our Z lies between Z1 and Z2. That is the area to be found. Fine. Now the next diagram is Z1. We placed it to the right side of the vertical line. We can see it. Next Z2. 1.73. That is also positive, that we placed it. But here maybe a small doubt it may ring in our mind, that is why we have to place this Z2 here, why can't here? There is a possibility will be there, few percentage of the students they may get it. The answer is the Z1, the point is 0.8. We know this goes on up to infinity. This point is 0.81. This point is 1.73. That is, it is higher than, more than 0.8. That is the reason Z2 is placed here, not here. Yes. Now, this shaded part area we have to find. So now the question is there. This is the fair diagram. Yes. That is Z1. We replaced it by 0.81. Z2, we replaced it by 1.73. This shaded part we needed. So up to here, first we are calculating area of Z2. We are subtracting this part, area of Z1. Then we are obtaining the shaded region. Our Z2, using the change of scale, 1.73. Z1 is 0.81. Using the normal distribution table, the result is 0.4582 minus 0.81. This particular point, what is that area? Using the table, we obtained 0.2910. So the modulus of this subtraction, we have done it 0.1672. So this is the question we are discussing. The first part of this question we completed. So the change of scale 0.81. This is the rough diagrams, bell shaped, and we placed it here, and we moved the fair diagram. Finally, we obtained the result 0.1672. But one more section is there. Yes, minus 1.43, x lies between 6.19. So we are now very familiar with these problems now. X lies between x1 and x2. When x1 equal to minus 1.43, it is converted into z1 equal to x1 minus mu by sigma. The x1, the value is minus 1.43. The mu and sigma, it is 1 and 3. So minus 2.43 divided by 3, which is equal to minus 0.81. The next point is x2 equal to 6.19. Z2 equal to x2 minus mu by sigma. We are substituting the particular places, the respective values. 6.19 minus 1 by 3, we obtained minus 5.19 by 3, which is equal to 1.73. The probability of minus 1.43 less than or equal to x less than or equal to 6.49. Yes, the name x1, 6.19 name x2, x1 converted into z1, x2 converted into z2. The first we are concentrating the rough diagrams. Z1 we obtained minus 0.81, Z2 1.73. Clear picture, this is negative. Negative, if it is the left side of Z equal to 0, it should be placed. So the place, how they are placed, we can see it. Yes, it is placed in the left side of to this point. Our Z2 is positive 1.73. So right side of this, the point, it is placed. Now our question is, Z lies between Z1 and Z2. This area to be found. With the help of normal distribution table, we can take the help for the calculation. So we can concentrate the fair diagram now. So we plotted it. This is the shaded one, which is colored in pink color. The shaded part area we have to find. So Z1, what we obtained the value for this particular problem, minus 0.81. Our Z2 is 1.73. So it's very clear picture. First we can find this part. That this part to be found, that is area of Z1. Next this part, that is complete this area, that is area of Z2. Both if you are adding, the total part we will be getting. Z1 is replaced by its value minus 0.81. Z2, the value is 1.73. Using the normal distribution table, the values are replaced. That is 0.2910 plus 0.4582. The final answer is 0.7492. So the table values, we can see it. This is the first one. Two sections are there in this particular problem. Z1 is 0.81, the first section. Yeah, we can see it here. Yes. Minus 0.81, how to be placed, we can see it. We needed 0.81, 0.8, 0.01. So yes, here 0.8 is there. We can move. Yes, we obtained the result. Next, we wanted 1.73, 1.7, 0.03. So now 1.7, we can move. Yes, this is the thing. This is the way we have to pick out the values from the normal distribution. The next one is minus 0.81. That is the second section of the problem we did. But here there is no negative positive. The area we are calculating. This then, why this negative sign? That is a question, the doubt it may come. Only the thing is there, if it is negative, the normal distribution to place it. If it is negative, we will move to the plotting the point left side. Whereas finding the area to pick the values, just we will be seeing 0.81 only. Yeah, we will come to a conclusion of this topic, area under normal curve. First, this topic, when mu and standard deviation, mean and standard deviation, if they are given, how to find the area. Normal curves, we used it. Different types, some 3 types of normal curves we discussed. Yeah, particular video, separate video which is done under normal curves also. In that completely all the curves are discussed. Students can utilize that. Yeah, we can see it. This is the first curve we discussed, that is Z1 greater than 0, Z2 greater than 0. This is the second curve we discussed, Z1 less than 0, Z2 greater than 0. Here Z1 is greater than 0. Only few curves we discussed it. And we move to the first problem. That is X lies between 26 and 40. And X is greater than or equal to 45. How to deal? The second one, X lies between 30 and 60, but it is very different one. That is 1000 students. The result should be multiplied by 1000. The next one is X lies between 3.43 and 6.19. Here we obtained the result Z1 equal to 0.81. The same question, some little bit different. That is before 1.43, now minus 1.43. The result what we obtained is minus 0.81. What are the differences are coming? If the values are changed, that we discussed in this video lecture very clearly. This is the normal distribution table. That is also how to use this normal distribution table. We discussed in detail about it. Everything it is done using this scale. This scale x1 minus mu by sigma. Completely using the scale, the data which are converted into Z points. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.